Hello viewers, welcome back to BakoMaths, and to this lesson we'll be looking at substitution in logarithm. That is part 2 of it. And if you have not subscribed to this channel, kindly subscribe so that when new video is being uploaded, you'll be the first person to be notified. Now let's get started. So in example 1, it says given log 5 base 3 to be equal to 1.465 without using tables, evaluate log 25 base 3 plus log 15 base 3. Now the whole idea is that we have to express the given logarithm to its basic form, and at the end there should be the existence of log 5 base 3 so that we can substitute its value, and then that will help us to get the final solution to log 5 base 3 plus log 15 base 3. If that is what is in mind, then we should write our solution as the logarithm of 25 base 3 plus the logarithm of 15 base 3. Now with this given logarithm, it should be expressed as 1 product of 2 or more numbers, or a quotient of 2 or more numbers, or a base and exponent of a given number. So since there are 2 logarithms, we can express it in these 3 ways. Now considering the log of 25 base 3, 25 can be expressed as 5 exponent 2. That is a base and exponent. So at this point, we're going to have here as the logarithm of 5 exponent 2 base 3 plus, in the same way we look at log of 15 base 3, the 15 here can be expressed as product of 2 numbers by considering 3 and 5. So that is the logarithm of 3 times 5, and that gives us 15. Now, not forgetting that it has the base 3, so we'd have to bring that one too. So we bring our 3 here. Now, when we look at logarithm of 5 exponent 2 base 3, it can be rewritten as 2 logarithm of 5 base 3. And this is a typical application of the laws of logarithms. Now we have plus. When we look at logarithm of 3 times 5 base 3, it has been written as a single logarithm, and we can expand by using the laws of logarithms. And at this point, we are going to have here as the logarithm of 3 base 3 plus the logarithm of 5 base 3. Now when we look at the question given to us, we were given the values of log 5 base 3 and log 5 base 3 here. So we can further break this down by considering log 3 base 3. That's when we said the logarithm of a number to the same base gives us 1. So we are going to have here as 2 multiplied by, now log 5 base 3, its value was given us 1.465. So just do that substitution, and we have here as 1.465 plus, like we said, the logarithm of a number to the same base gives us 1, so that is 1 here, plus log 5 base 3 was also giving us 1.465, and when we sum whatever we have here at the end, we are going to have our final solution as 5.395, and that becomes the solution. So it implies that therefore the logarithm of 25 base 3 plus the logarithm of 15 base 3 is equal to 5.395, and it becomes the solution to this question. Now let's check out the next example to this set of video. Now in example 2, it says that if log 2 base 10 is equal to 0.3010 and log 7 base 10 is equal to 0.8451, evaluate log 35 exponent 2 base 10 without using calculator or tables. Now remember that when we are solving questions in substitution in logarithm, what we have to do is that we have to consider the given logarithm. And the given logarithm we are solving now is the logarithm of 35 exponent 2 base 10. Now this given logarithm, it should be a logarithm that can be expressed as product of two or more numbers, the quotient of two or more numbers, or a base and exponent. So before we do, we can see that the 2 here, that's the exponent, can be written as a coefficient to logarithm of 35 base 10 by using the product in this law from the laws of logarithms. Now we have here as 2 logarithm of 35 base 10. Now we have to simplify 35 base 10 in such a way that we can get log 2 base 10 or log 7 base 10 or both, so that we can substitute their respective values into the simplification of log 35 base 10. So if that continues, then we are going to maintain the 2 here, and then when we look at log 35 base 10, it is a single logarithm, and we can expand by writing it as a product of two numbers, so multiplied by the logarithm of 7 times 5, and that actually gives us 35. Now if that continues, we can also see that log 7 times 5 is also a single logarithm and can be expanded by applying the laws of logarithms in such a way that at the end they are going to add. So we have 2. Now we bring our brackets, so we have the logarithm of 7 base 10 plus the logarithm of 5 base 10. Now the value of log 7 base 10 was given the question, and we have it here. And then we have also been given logarithm of 2 base 10, but in this simplification where we've reached, there is no log 2 base 10. So it means that we have to simplify it further, considering log 5 base 10 in such a way that we get log 2 base 10, and then we do the necessary substitution. Now we have 2 multiplied by, so it's equal to 2 multiplied by, so now since we have log 7 base 10 in our question, we maintain it, and our focus now comes on log 5 base 10. Now in what way can we express log 5 base 10? So expressing log 5 base 10, we have to deal with the quotient condition. That is by writing this as the logarithm of 10 out of 2 base 10, knowing well that 10 out of 2 gives us 5. So that is that. Now we close it. So we have our 2 maintained here, and then the same logarithm of 7 base 10 also maintained, plus when we look at this single logarithm, that is log 10 divided by 2 base 10, it is a single logarithm, and we can expand by using the laws of logarithms, which means we are going to have here as the logarithm of 10 base 10 minus the logarithm of 2 base 10. Now having known that, we can break it down, and our simplification now becomes 2 multiplied by, since you know the value of log 7 base 10, we maintain the same thing, plus, now we said the logarithm of a number to the same base gives us 1. So it means that log 10 base 10 is equal to 1 minus the log 2 base 10 here. So now we've been able to reach target, that is we having log 2 base 10. So at this point, we are going to do the necessary substitution. Now in the question, we're given log 7 base 10 as, so we refer and we can see that log 7 base 10 was given as 0.8451. So do the necessary substitution here, and we have 0.8451 plus 1 minus log 2 base 10 was also given the question as 0.3010. So at this point, we are going to have here as 0.3010. Now, when we add the numbers in the bracket, then we are going to have our answer as 1.5441. So 1.54, so we have 5 here, 4, and we have 1 here. Now, when 2 multiplies 1.5441, then we are going to have our solution as 3.0882. Now this implies that, therefore, the logarithm of 35 exponent 2 base 10 is equal to 3.0882. And this is how we can find the value of log 35 exponent 2 base 10 without using calculator. And example 3 says that suppose log 2 base 10 is equal to 0.3010 and log 3 base 10 is equal to 0.4771. Calculate without using logarithms tables the value of I log 50 base 10 minus log 40 base 10 if log 5 base 10 is equal to 0.6990 and I that is log 0.24 base 10. So in any case, we are going to use the values of log 2 base 10, also log 3 base 10, and also log 5 base 10 in finding the values of the questions given to us here. Now let's tackle them one after the other. So we have our solution here, and with the first one, it says that you find the value of log 50 base 10 minus the logarithm of 40 base 10. Now we know log 50 base 10 minus log 40 base 10 can be written as a single logarithm by considering the laws of logarithms. And once they are subtracting, we can write it as the logarithm of 50 divided by the logarithm of 40 base 10. So we divided because the logarithms are subtracting and they have the same basis. Now at this point, we can see that the 0 here is going to cancel the 0 there, and what is left is the logarithm of 5 out of 4 base 10. Now we can see that it's a single logarithm again, and we can expand by using the laws of logarithms. So here we have the logarithm of 5 base 10 minus the logarithm of 4 base 10. Now remember that in the question we're given the values of log 5 base 10 and then that of log 2 base 10 and log 3 base 10. So in any case, where we've read, we can see that there is log 5 base 10, but there's no log 2 base 10 or log 3 base 10. So it means that we have to simplify log 4 base 10 so that we get any of log 2 base 10 or log 3 base 10 in it. Then we do the necessary substitution. Now since we have the log 5 base 10 here, we maintain it, and we know that log 4, considering 4, can be written as 2 exponent 2. That is the logarithm of 2 exponent 2. That gives us 4 base 10. And when we look at the logarithm of 2 exponent 2, the exponent 2 can be written as a coefficient to the logarithm here, and that becomes 2 logarithm of 2 base 10. And then we have our logarithm of 5 base 10 here. Now at this point, we can see that we have log 2 base 10 here and log 5 base 10. So now we are going to do the substitution. Now when we look at this side, log 5 base 10 was given as 0.6990. So here we write as 0.6990 minus 2 multiplied by, now log 2 is also given as 0.3010. So we come and write here as 0.3010. Now we maintain the 0.6990 minus, so 2 multiply 0.3010, we are going to have here as 0.6020. And when we subtract these two, we are going to have our final answer as 0.0970. So this implies that, therefore, now this implies that the logarithm of 50 base 10 minus the logarithm of 40 base 10 is equal to our solution as 0.0970. And this becomes the solution to our question. Now let's try the next one. And the last one, we were given that we should find the value of the logarithm 0. So it's logarithm of 0.24 base 10. But before that, let's divide our worksheet so that we present our solution so nice and neatly. Good. Now with that's the logarithm of 0.24 base 10, we can see that we can rewrite 0.24 as, so at this point it can be written as, so it's equal to the logarithm of 24 divided by 100 base 10. Now if that's the case, then we can expand by writing it as the logarithm of 24 base 10 minus the logarithm of 100 base 10. Now we can see that there is 24 here, and we want to express 24 in such a way that we get either log 3 base 10 or log 2 base 10 or log 5 base 10, so that we can substitute their values. Now, so this implies that when we take 24, we can express 24 as product of two numbers by considering the logarithm of 8 times 3. So 8 times 3 gives us 24. Now there is a base 10 here, so we write our base 10. And then also when we look at the logarithm of 100, 100 can also be expressed as 10 exponent 2, and then we have our base 10 here. Now if that continues, then when we look at the logarithm of 8 times 3 is a single logarithm, and we can expand by using the laws of logarithms. So it implies that at this point we are going to have here as the logarithm of 8 base 10 plus the logarithm of 3 base 10 minus, now this exponent 2 can be written as a coefficient to logarithm of 10 base 10. Now if that continues, then we can see that 8 can also be expressed as 2 exponent 3, that is a base and exponent. So we have here as the logarithm of 2 exponent 3 base 10 plus the logarithm of 3 base 10. Now we said that the logarithm of a number to the same base gives us 1. So for log 10 base 10, we are going to get 1 here. Now with this exponent 3, it can also be written as a coefficient to the logarithm of 2 base 10. So we have 3 logarithm of 2 base 10 plus logarithm of 3 base 10, and 2 times 1 gives us minus 2. Now at this juncture, we can find that, or we can see that log 2 base 10 was given the question. So we have the value of log 2 base 10 as 0.3010, and that of log 3 base 10 as 0.4771. So by substitution, then our solution now is equal to, so we have 3 here, and log 2 base 10, remember, is given as 0.3010 plus log 3 base 10 was given as 0.4771, and we have our minus 2 here. Now when we multiply 3 by 0.3010, then we are going to have 0.90. So you have here 0.9030, and then 0.4471 minus 2 maintained, so plus 0.4771 minus 2. So now when we sum all these three values, then our final answer should be negative 0.6199. So this implies that, therefore, you can see that the logarithm of 0.24 base 10 is equal to negative 0.6199. So this becomes the solution to this question. Now let's move to the last set of examples for today's video. And that is example 4. So example 4 says that given log 2 base 10 to be equal to 0.3010 and log 7 base 10 to be equal to 0.8451, calculate without using logarithms tables the value of 1 log 2.8, and II says that given n exponent 0.8924 to be equal to 2.8, use your result in I to simplify. So the first thing is that we have to simplify log 2.8, and then we have to apply log 2 base 10 and log 7 base 10 in our solution. Now the first one is what we are going to deal with, and that says that we should deal with log 2.8. Now this log 2.8 implies that the base here is 10. So if the base not indicated, then it should be noted in our minds that it has a base of 10. So we write the base 10 here. Now we ask ourselves, what is 2.8? We all know that 2.8 is the same thing as 28 out of 100. So at this point, you're going to have here as the logarithm of 28 divided by 100. We have our base 10. Now we can expand this by having the logarithm of 28 base 10 minus the logarithm of 100 base 10. Now at this point too, we can see that 28 is a number that can be broken down by considering the product of two numbers, and in the product of these two numbers we can consider 7 and 4. That is 7 times 4 gives us 28. So at this point we have the logarithm of 7 times 4 base 10, and then we know that 100 can be written as 10 exponent 2 base 10. So looking at 7 times 4, that is the logarithm of 7 times 4 base 10, it can also be expanded by using the laws of logarithm, and here we are going to have the log of 7 base 10 plus the log of 4 base 10. Now when we look at logarithm of 10 exponent 2, the exponent 2 can now be written as a coefficient to logarithm of 10 base 10. Now in the question, remember that we were given the values of log 7 and that of log 2. Yes, we were given log 2 and log 7. But in our simplification, we have only log 7 here, which means that we can further simplify log 4 base 10 for us to get log 2, so that we do the necessary substitution. Now at this point, we have here as log 7 maintained here, and then plus 4 can be written as 2 exponent 2. So we should have the logarithm of 2 exponent 2 base 10 here minus 2. Now the logarithm of a number to the same base gives us 1, which implies that log 10 base 10 gives us 1 here. Now if that continues, then we can further simplify. We have here as log 7 base 10 plus 2 log 2 base 10. That is writing this exponent as a coefficient to the logarithm. Now we have 2 times 1 gives us minus 2. Now that we know the value of, we have been able to simplify for us to get log 2 and log 7, we do the necessary substitution, and for log 7 base 10 we know its value to be 0.8451. So right now we write the same thing here as 0.8451 plus 2 multiplied by, and for log 2 we know its value to be 0.3010. So we can write here as 0.3. So now let's write it well. So it should be 3010. So 0.3010. We have minus 2 here. Now when we sum everything, then our solution now becomes 0.4471, which implies that the logarithm of 2.8 base 10 is equal to 0.4471. Now, the question didn't end there. Given that n exponent 0.8924 is equal to 2.8, use your result in I to simplify. So it implies that at the end, in simplifying the question here, we should get log 2.8. Then later we do the substitution using the value we found for log 2.8. Now let's get started with that. And the second question said we should find n if n has an exponent of 0.8924, which is equal to 2.8. Now in solving this, what we can do here is to apply the common logarithm to both sides of the equation. So at this point, you're going to have logarithm of n exponent 0.8924 base 10, which is equal to the logarithm of 2.8 base 10. So already we have been able to find the value of log 2.8 base 10 to be 0.4471. So you're just going to do substitution with that. Now, before we continue the substitution, we can see that at the left hand side of the equation, we can write the exponent as a coefficient to the logarithm here. Now, it's going to imply we have 0.8924, now the coefficient, to the logarithm of n base 10. So we have here as log 2.8 base 10. So now in finding the value of n, then we can divide both sides of the equation by the coefficient of n. That is 0.8924 divided by 0.8924. Now we can see that this is going to take away that, and what is left is the logarithm of n base 10, which is equal to, now we know the value of log 2.8 base 10, and that we found to be 0.4471. So doing that substitution, then we are going to have 0.4471 divided by 0.8924. Now, when 0.4471 divides 0.8924, our solution now becomes 0.5010, and then we have the logarithm of n base 10. Now what we can see here is that we can see exponential form here. Sorry, we can see logarithmic form. So this is a logarithmic form, and we can change to exponential form, knowing well that the n is going to come here, and then the 10 is going to have an exponent of 0.5010. Now it means our solution now is going to be n to be equal to 10 exponent 0.5010. So now we ask ourselves, what is 10 exponent 0.5010? It's nothing but 3.1696, and this becomes the value of n. Simply gotten its solution. So this ends today's video, and thanks for watching. Kindly like, comment, subscribe, and share. This is BakoMaths. See you in our next video.